Yeah, hi friends. My name is Rick Chandan and welcome back to my channel Energy and Environment Education. Friends, this is chapter 2.3, the STEAM system. It's a very important chapter. I hope you must have gone through the other chapters also that videos I have made and uploaded in this particular channel, Energy and Environment Education. And this is also an important chapter, that is chapter 2.3, the STEAM system. And this is a part A. I have divided the entire chapter into different parts such that it is easily understandable by you and you can easily go through the entire chapter part by part, friends. It's a part A. Similarly, I'll be making other parts also on this particular chapter and will upload in coming days. Meanwhile, you can also go through the other video that I have uploaded on different chapters, basically on BW exam. So any aspirants who are looking forward to take exam this year or in coming years for energy auditor exam or energy manager exam, for them these videos are very much important, friends. And all these chapters are equally important because there are a lot of questions you can expect from these chapters, friends, in the exam. I have given number of tips also, important questions I have highlighted which can come in the exam, which part of the chapters you must more focus on, and what type of question you can expect in the exam. Those things also I have dealt with in different chapters or different videos that I have made in this particular channel, friends. So please go through the different videos that I have uploaded in this channel, and also will be going to upload more such videos in coming days, friends. So please be connected with me, and also a request, as I make in other videos also, please do subscribe my channel if not yet, because that will motivate me to prepare more such videos. And I have been preparing these videos. These are free of cost. You do not pay any price for that. Only you need to subscribe the channel, and it's free of cost. Also, it will not take too much time, friends. Few seconds are required from your side. Just an appeal to you. Please go to the chapters, go to the videos, and please do subscribe my channel. Also like it and share it with your friends and colleagues, whoever you think that these videos can help them also in their preparation for the exam, friends. Also, I would like to add here, not only for this exam particular, friends, any engineering students, any from mechanical side or electrical side, for them also these videos are equally important because these chapters are very much important from them to understand also, friends, as a technical point of view. So please watch these videos. Hopefully this will help you in preparing for your exam, preparing for yourself also on these chapters, on this particular syllabus, friends. So that's all for today, and let's start the video without wasting further time, friends. So before we begin, friends, let's have the let's see the content first. So in this particular video, in this particular part A of this chapter, I'm going to basically start with the introduction of the STEAM system, and also will give you some highlights on the properties of STEAM. So these two topics I'm going to discuss in this particular video, friends, and these two topics are very much important. First of all, you need to understand what is STEAM all about, and also you need to understand the properties of STEAM. So this is the content of this particular video, friends, and hopefully this will help you prepare for exam in a better way with this content, friends. So to start with, first of all, you should know what is Steam. I think most of you are aware of what is Steam all about, so it's not a new thing for you, but you should understand why this Steam is used and what are the characteristics of Steam, why it is so useful for us. First thing you need to understand why or you can say the areas where the Steam is used. The Steam is used for generating power and also used in process industries such as sugar, paper, fertilizer, refineries, petrochemicals, chemicals, food, synthetic fiber, and textiles. So these are some of the major industries or sectors, you can say, where this steam is used in large quantity, friends. So these are the important areas you must understand, you must learn. Also, you must remember, friends. They may ask you in the exam to name some of the industries or process industries where steam is used. So you can name some of them from this list, friends. Then the next question comes the characteristics of steam. Why what are the characteristics of steam? Why it is made? Why it makes it so popular and useful in the industries? So basically, these are some of the four characteristics of steam. Why it is so popular and so useful in industries, basically, friends. So the steam has highest specific heat and latent heat. This is the first characteristic. Second characteristic is the highest heat transfer coefficient, easy to control and distribute, and cheap and inert. So these are the 4 points. I'm not going to explain you in detail here, but you must at least understand these 4 points and remember these 4 points because it's a very important question as the exam is concerned. In the exam, they ask you to list out the four characteristics, or they will ask you not the four they'll ask this. Generally, they'll ask you list out the characteristics of steam, why it makes or what it makes so popular and useful for the industry, friends. So you may be asked to name all these four characteristics, and also they may ask you to briefly explain them. So it's not so tough to understand, not so difficult to explain it. So I'm not going to explain you in for the timing here, friends, but you should have some thing in your hand as an explanation, friends, for all these 4 points when it comes in the exam. Now this part basically makes you understand of how the steam is formed. So basically what happens, water can exist in the form of solid, liquid and gas. This is not a new thing for you. Any water can exist in different forms, in the form of ice, in the form of normal water, or can say in the form of steam also. If heat energy is added to a water, now suppose any water is there and water is at a normal temperature range, its temperature rises until a value is reached at which the water can no longer exist as a liquid. So what happens, initially the water remains at a liquid form at a normal temperature. Now you start heating it, so slowly the temperature starts increasing, and we call this the saturation point. And with any further addition of energy, so the water will boil off as steam. Now as the temperature increases at a certain point, at a certain level, it stops increasing, temperature stops increasing. But further, if you start keep hitting the water, then what happens, the water starts boiling, and this evaporation requires relatively large amounts of energy. And while it is being added, water and the steam released are both at the same temperature. I mean, at that temperature, what happens, water basically converts into steam form. So initially, if the water remains at a liquid form, temperature starts increasing. When you heat it at a certain point, the temperature stops increasing. But if you continue heating it, it absorbs more and more heat, and then the formation, transformation of the form starts. I mean, one form to other form it goes. I mean, from the liquid form, it transforms into the steam form or gaseous form, friends. So this is the aspect that you should understand about the water, friends. So again, these are two different types of heat that you must understand, you must remember, or they may ask you to define it, also briefly explain it. So the sensible heat and latent heat are the two keywords, key terms that you should understand and remember, friends. The heat required to change the temperature of a substance is called this sensible heat. I mean, if the water, like suppose of 1 kg is there, uh, temperature is 25 degrees centigrade, that is normal temperature, the water is present, and you start heating it. So slowly when it starts absorbing the heat, like suppose initially it was 25 kilocalorie heated, by adding 25 kilocalorie, the water is brought to a boiling point of 100 degrees centigrade. So initially what happens, when you start heating it, slowly the water starts absorbing heat, and the temperature also increases at a point 100 degrees centigrade. What happens, it comes into a boiling point. So that heat which is used to increase the temperature of the water from its initial stage to its final stage, at this stage, this is called the sensible heat. Here no transformation of the state change is not taking place here, friends. Only the temperature is increasing. So temperature increases from 25 degrees centigrade to 100 degrees centigrade, but there is no change of state is there. Water still remains in a liquid state, but temperature is increasing here. That heat absorbed is called the sensible heat. Now coming to the latent heat, like suppose if you continue to heat it to change the water into steam. Now water is at temperature of 100 centigrade, it starts boiling. Now the temperature is is constant, but if you keep on supplying the heat, that heat will be absorbed and the water will be converted into steam form. An additional 540 kilocalorie would be required to change into water from to water to steam form, friends. This quantity of heat required to change a chemical from the liquid to gaseous state, I mean from the water is changed to steam, or you can say from liquid state to gaseous state, that heat is called the latent heat. So any heat which is used to increase the temperature only, no change in state is there, that is sensible heat. But the heat that is required to change the state from liquid to gaseous form, that is the latent heat. So this is the two difference between, I mean, this is different between the sensible heat and the latent heat, that you must understand. Also you must remember, they may ask you to differentiate it, they may ask you to explain it briefly, or also they may ask you as a definition, friends. So these things are important for you to understand for examiners point of view, friends. So just an example here, for a boiler is operating at a pressure of 8 kg per centimeter square. Steam is saturation temperature is 170 degrees centigrade, and the steam enthalpy or total heat of dry steam is given by. So basically they ask you to calculate the total dry saturated steam value. In that case, the two enthalpies, enthalpy of the sensible heat and enthalpy of the latent heat, will be added together to calculate the total heat. So if total heat is required or for the dry saturated steam, friends, So if you want to calculate the total heat, in that case you have to add the sensible heat as well as the latent heat, friends. So if the sensible heat is 171.35 and latent heat is 149.46, these two are added to you get the value 660.81 kilocalorie per kg is the total heat of dry saturated steam, friends. Now, if the moisture content is there, like suppose if the same steam contains 4% moisture, then what happens in that case? The total steam, total heat of steam will be given by 171.35 remains same. That is the sensible heat remains same. In the case of the latent heat, now 4% is moisture. So what is dry part is 100 minus 4% is 0.96 you can say, or 96% you can say. So 0.96 you have to multiply the latent heat and you get the answer 641.23 kilocalorie per kg. This is very much important as far as the exam is concerned, because some sort of numerical based question you can get from this part of the chapter, friends, with this formula. It's a very simple formula, but you should understand the concept here, because maybe they will give you directly sensible heat and latent heat. They will ask you to calculate the dry saturated heat or steam, you can say. In that case you will use this formula. But suppose any moisture content is also added there in the steam, in that case you have to multiply this, not 4% but the 96%, this is dry part, into the latent heat, and then you get the answer, friends. So this is very much important as far as I am concerned. Also concept is very much important to understand, friends. Now coming to the steam phase diagram, this is also very much important as far as I am concerned. Either they will ask you to draw this diagram, or they will only give the diagram and name it A, B, C, and D, and also other parts. They'll just put it there to ask you to explain it. This all the different stages A, B, C, and D, which is marked here. So either they will ask you to draw the diagram, or they will give the diagram, name this as A, B, C, D, and they will ask you to explain this different stages and entire diagram, friends. So this is very much important. The steam phase diagram is very much important. Please learn it. Please draw it by yourself also. Either they will, if they do not give you the diagram, directly they will ask you to draw the diagram. So you must be able to draw it, friends. It's very much important for the examination point of view. Number of times the questions have come where they have given the diagram and they have asked you to explain, or they have not given the diagram, they directly they were asked to explain or draw the diagram and explain it, friends. So it's very much important as far as I'm concerned, friends. So as I said, first of all, you should learn to draw the diagram, and second thing is you should know what are the key points about this diagram, friends. What do you mean by A, B, C, D, what they show, and what are different stages which is explained here. So all these terminologies and what are the areas that is explained here has to be understood by you. So what is happening here from A to B, what is happening in B to C, what is happening in C to D, what is critical point, all these are questions that can come in the exam, friends. So if you see the diagram here, as water is heated from 0 degree to its saturation temperature, it conditions follows the saturated liquid line until it has received all of its liquid enthalpy, HF A minus B. So as I said in the earlier slide, HF is the enthalpy of the sensible heat. So now you can recall it, what is HF here. So if it is the A to B, if you are going here from 0 degree centigrade, it was at the normal, you can say, or not normal temperature, so at the temperature of 0 degree centigrade the water was present. Now we started heating it. So slowly what happens, the temperature increases as you heat, and it reaches a certain point here B. So this is the sensible heat here that was explained earlier in the slide, friend. So if you have not yet explained understood, please go through the earlier slides where the sensible heat was explained. So this is A to B, sensible heat is going on. This is the sensible heat area. Again, what happens in the B to C is the HFG, that is the this is the latent heat part, where the change of state is taking place of the water. So the temperature now from 0 to maybe it is 100 now, and here at 100 it remains same, temperature remains same. But what happens, the as you increase the energy, if you keep on supplying the energy, if you keep on supplying hitting it, what happens, temperature will remain same here, but the state will change from the water state to the steam stage, or liquid state to the vapor stage, that way. So B to C, what is happening here, this is the entire part where the latent heat is used, friends. So this is the sensible part, this is the latent part. So now you can recall it, what I had explained you in the earlier slides, friends, about the sensible heat and the latent heat. So this is very much important as far as exam is concerned. Also please understand the what is the different terminologies which explained here. So as you saw in the last slide, A to B, the sensible heat was there. B to C is the latent heat. This means here the steam is changing, I mean water is changing into the steam form. Now if you continue to supply more and more heat after the saturation is received here, I mean it already transformed into the steam form, water is now changed to steam form, but still if you are keeping on the supplying heat, once it has received all its enthalpy of evaporation, it reaches the saturated vapor line here. See, this is what. But if it continues to be heated after this point, now again if you're continuing heating, then at that time what happens, this steam will convert into superheated steam. The steam will continue to get more heated, and then it will convert into the superheated steam, friends. This is what about the A, B, C and the D part, friends. So these are the four parts. You can say the important areas which is very much important for you to understand: the sensible heat area, latent heat area, and the superheated steam area, friends. This is what explained in the steam phase diagram. So if they ask you to explain it, please make it for sure that you can understand. You can explain it in a better way, friends, in the exam. Now again, this is very much important point, friends. In this exam also they may ask you to define the critical point, to explain the critical point, or what is critical point in the steam phase diagram. It's a very important terminology that you must understand, you must remember, and maybe asked in the exam in a different way, friends. So basically, what is happening here, in from A to B, you understood sensible heat. There was no state change. B to C, temperature remains same, and the state change starts. I mean, there is a change of state from liquid to steam form, friends. Now what happens, temperature is now, you have increased the temperature here, now temperature remains same, but as you keep on supplying, slowly what happens, the water will start transforming into the solid, I mean vapor form, friends. This is the area, this is a point, critical point, where this transformation is actually taking place, where the starting to take place, friends, where the point at which the saturated liquid, so this was the saturated liquid, and the saturated vapor, here now vapor form is already starting, friends, is meeting here. This is the point at which these two are meeting, the transformation is actually taking place here. So this is the critical point, friends. So this is very much important to understand. Above the critical point only gas may exist. Now see, as this is the point where the actual transformation is taking place, so above this point, only the gaseous form will be present, no liquid form will be present, friends. So this is very important for you to understand. Also the critical point occurs at 374.15 degrees centigrade and 221.2 bar. These two figures you must understand, you must remember also, friends. In they may ask you as a fill in the blanks, or as a true false, any type of question, friends. This temperature and pressure of the critical point also is asked in the exam number of times, that you must understand, you must remember, friends. And this is the extract from the steam table. So you need not learn this table, do not by heart this table, but you should understand this table all about. So basically the same concept is here used, which I have already explained in the previous slides: the sensible heat part and the latent heat part. So if the pressure, like suppose it is 1 kg per centimeter square and temperature is 100 centigrade, so at that time the sensible heat for the water is the 100.0.09, friends, and the latent heat will be 539.06. So if you add both of them, then you get this figure here, friends. So the steam, you can say, will have this particular value of so enthalpy of the steam will be 639.15, friends. So this is what basically this table says. So likewise for the different pressures and temperature, the sensible heat and the latent heat is given in this particular chart, in this particular table. You need not learn it, but at least you should remember, I mean you should understand this table all about, friends. So if they ask you in numerical based question, if they give you this table, and from there if they want to they ask you to extract data, so in that case you must understand this is what this is the sensible heat, and this is the latent heat, and this is the total heat of the steam, friends. So all these things has to be understood, and you must use it, apply it in your exam, friends, during calculation of the numericals, friends. So that's all for today, friends. This is part A I have completed, and will be also continuing with the part B. I hope this part A has given you some insight about the steam property and steam all about. And likewise, I'll be also dealing with other parts of the chapter in part B, friends. Hopefully, this is a it is important video for you. You must have got some insight, some important points or tips you must have got from this particular video, friends, also. And hopefully, same thing will be repeated in the other videos. So please be connected with me, and you can go through the different videos that I have posted on my channel. All these videos are equally important, they can help you in your exam preparation, friends. And before I leave, friends, this is the YouTube channel I have, Energy and Environment Education. please do subscribe the channel, friends, because this will really motivate me to prepare more such videos. It's a free of cost. It won't take your time. It will just few seconds are required to subscribe the channel, but this is a really motivating factor for me. This list lets me know also whether you are liking the video or not, whether the your content that I'm presenting here, or the video content or video, the way I present it is useful for you or not. So also please do connect with me, and also please press the bell icon, so that you get the instant notification as soon as I post a new video. As far as connection is concerned, you must connect with me, friends. This is my mobile number, this is my email ID. Please drop your comments, any query if you have, any feedbacks if you have regarding the content of the video, or any other thing that you feel you must share. Those things please do share with me, friends, and this will help me to understand more you also better way, friends, what is your expectation all about. And that's all for today, and we'll meet in a new video with a new content. And this will really maybe those videos also can be really useful for you in your exam, friends. So that's all for today, friends.